Now, you've actually done these kinds of problems before, solving quadratic equations using square roots. As a reminder, you will sometimes see y in these equations, and we replace the y with a 0 because we're trying to find the x-intercepts. If I graph a quadratic equation and I get a parabola, I want to find these values where it crosses the x-axis. If I wrote the ordered pairs of those, it would always be something for x and then y is 0. Because it's right on the x-axis, it's not above or below it. That's why I replace the y with a 0 to solve for x, because those are the points we're looking for. So the first thing I'm going to do is to replace the y with a 0. Well, think about it. When y is 0, this equation becomes x squared equals 16. Now I want to undo the square on the x, and it's the only thing on that side is the thing that's being squared. That's important. I want to undo the square. The inverse operation of a square is a square root. So I have to square root that side so that I can just get x. But I can't do something to one side of the equation without doing it to the other side, so I also have to square root the 16. I need to remember this positive and negative in front of it, though, because it says what number could I multiply by itself and get an answer of positive 16? Well, one of my choices is negative 4. Negative 4 times itself is positive 16. The other choice is positive 4. Positive 4 times itself is 16. So that's that plus and minus to get me my two solutions. Remember, that means if I graph this parabola, it would cross the x-axis at positive 4 and at negative 4. I also know from the transformation work we've done that it's going to cross the y-axis all the way down at negative 16, and that it doesn't have a horizontal translation at all for the vertex. So, very roughly speaking, this parabola opens up because the coefficient of x squared is positive. It has translated down 16 units, and the x-intercepts, the zeros, the solutions, are at x equals negative 4 and positive 4. Now, in this case, again, think about where this negative 81 would have started. Typically, it would have been over with the y. So x squared equals y plus 81. So what I know is there's no horizontal translation of the vertex, but the vertex has translated 81 units down, so at negative 81. If I solve this, I put 0 in for y, I get x squared minus 81 equals 0. Do not square root the left side of the equation yet. The only thing that's being squared on that side is the x. I need to isolate that first. So what I'm going to do is add 81 to both sides of the equation to get rid of this minus 81 on the left, and I end up with then x squared equals 81. So the thing that's being squared is by itself on the left side of the equation. Now I square root to eliminate the square, which means I also have to square root the 81, but don't forget both the positive and negative roots. So x equals negative 9 is one of my solutions, and x equals positive 9 is the other solution, which means if I graph this parabola, it crosses the x-axis at negative 9 and at positive 9, and obviously the scale's not the same on these two axes, and the vertex is down at negative 81 on the y-axis. It opens up because when y is on one side and the x squared is on the other, the coefficient of the x squared is positive. One thing to notice, remember what's happening when that whole side of this equation is being squared. The square root undoes the square. So it's kind of like they cancel each other out. Addition undoes subtraction, multiplication undoes division, and then I'm left with just the x. In this equation, if I replace the y with 0, 0 minus 3x squared is a negative 3x squared equals negative 75, and that's a little bit thicker than I want. So in order to square root this side, first I need to get rid of the negative 3. It's not being squared, only the x is. So divide both sides by negative 3, And I'm putting this in a different color because you don't have to show that part, to get x squared equals positive 25. Now I'm down to where the thing being squared is by itself, so I square root the x squared to eliminate the square and just get x. But I have to look at then square rooting the other side and looking at both the positive and negative roots. So x equals negative 5 and x equals positive 5. So if I sketched a graph of this parabola, now think about what happens here, and let me undo this. Usually the x squared and the y are not on the same side. So the x squared, I would add 3x squared to get it to the other side, and I would have a positive 3x squared. And usually then this constant is over with the y. So I'd have y plus 75 equals 3x squared. So when I graph this, again, the vertexes move down to negative 75 on the x and the y-axis. There is no horizontal translation. Here, on the next one, is a horizontal translation. I'm adding or subtracting something from the x before I square it. Here, that's not being done. I know that it crosses the x-axis at negative 5 and at positive 5. It has a vertical stretch of 3. It opens up because when y is on one side and x squared is on the other, the coefficient of the x squared is positive. So even though it looked like the coefficient of the x squared was negative, first I had to get it on the opposite side of the equation, away from the y. This is the first one that has a horizontal translation to the vertex. So what I know immediately is this. The vertex is at positive 2, and I would have to subtract 1 from both sides to move this over, and I would have x minus 2 squared equals 49 plus y. And so it's moved down 49 units. There's my vertex, which means this. One of the things it means. Here's my line of symmetry that goes down through the vertex. This thing is symmetric about that, which means all of a sudden my x-intercepts aren't going to be opposites of each other. It's taken this and shifted it over. At this point, I could also have replaced the y with a 0. So x minus 2 quantity squared equals just 49, because 49 plus 0 is 49. Now, the thing that's being squared isn't just the x, it's the whole x minus 2. It's on one side of the equation by itself, so now, to get rid of that square, I have to square root this whole thing. The square root of x minus 2 quantity squared, and then I have to square root the other side, remembering both the plus and minus, the positive and negative roots. So I square root 49 and get 7, but my answers are not x equals negative 7 and x equals positive 7 like they would have been here. What I get when I square root this side is the square root and the square sort of cancel each other out, and x minus 2 equals negative 7, and x minus 2 equals positive 7. Then if I added 2 to both sides here, this one would be x equals negative 5. Adding 2 to both sides here to solve for x, x equals positive 9, which means positive 9 and negative 5, are my x-intercepts. Goes down through the vertex and back up through. So it's the same distance away from the vertex horizontally, but since the vertex has shifted, these are not just opposites of each other anymore. This one's a little bit more complex because it's got a lot more things going. But if you think about it, I ultimately, before I square root anything, this thing that's being squared has to be on the left side of the equation or the right side by itself. So I don't want the 2 out in front of the parentheses, and I don't want the plus 5 at the end. The first thing I'm going to do is to move my constant to the right. So to get rid of a plus 5, I would have to subtract 5 from both sides, and I would end up with 2 times x minus 8 quantity squared equals 128. I replaced the y with a 0. 0 plus 133 is 133, minus 5 is 128. I still need to get rid of this 2, though, on this side, so I'm going to divide both sides by 2. I am not going to distribute it because this square out here would have to be done before I distribute, but I don't want to actually take x minus 8 times itself right now. So I end up with a big blob on the screen. I end up with x minus 8 quantity squared equals 64 when I take 128 and divide by 2. Now, the thing that's being squared, the x minus 8 is being squared. That's by itself. So I square root that side, x minus 8 squared, and the square root of that equals the positive and negative square root of 64. So x minus 8 equals negative 8, because the square root of 64 is 8, and x minus 8 equals positive 8. When I add 8 to both sides to isolate the x here, x equals 0. When I add 8 to both sides to isolate the x here, x equals 16.